Here's a quick presentation of the Pyrograph software and how to use it. So once you are logged in with your username and password, you will get to this page. So we move from top to bottom, and then we move through the tabs from left to right. So the first 3 cells are optional for you to enter some information and identify your different simulations. Then we get to mode. Mode, we have the choice of tempering, for tempering after hardening or after quenching, and then stress relieving for stress relieving of cold form parts. Then you select your oven. So usually when we activate your account, we will give you access to the oven that you own only, not because we don't want you to simulate with other ovens, just to clean the list and make it easier for you to use. So if you want to do simulation with another oven model, just send us an email and we'll add it to your list. So once done, we click next. Then we select the part type. So this is a closed wound, either extension or torsion spring, or a part that is more like a tube than a spring. Here we have a torsion spring, which is either as big OD as it is long, or bigger OD than it is long. Then we have a compression spring. So for this example, I'll use the compression spring. Unit system, up to you. If you have metric or imperial data. Then the material, oil tempered. So the most common spring material are there. So I'll go with chrome silicon for this example. Wire diameter, overall length, overall diameter, part weight, then the loading. So bulk random is for parts that are randomly falling on the belt, and organized align is for parts that we want to control the positioning on the belt. So for example, if we have really long spring that needs to be loaded either lengthwise or widthwise on the belt, then we'll choose organized. Or if we are loading the oven with a robot or pick and place, and that the position of the part is always the same with the same center to center distance, and we'll choose organized. I can choose it for this example. Then parts per hour. So you see that the software has already calculated the stress relieving temperature. Once you get used to the software, if you know you want your parts to reach some specific temperature, you can just overwrite this value. But I'll leave the calculated one for now. So as I choose organized loading, we have this new tab that got inserted in the flow. So here we will choose if the part is loaded lengthwise, widthwise, or standing up. So I'll go with widthwise. Here we can, if we want to have some spacing in between the parts, so we can either change the center to center or change the spacing. So here's the result. So the software has calculated that cycle time of 6 minutes to reach the parts per hour requirement that I entered in the parts tab. As you can see, I requested 1800 parts per hour, and with 6 minutes we get 1920, so we get a little extra parts. And the stress temperature for this material at 6 minutes has been calculated at roughly 765 F, and so both zones were set at 765 F. So I can redo it with bulk just to show. Wire diameter, I'll put okay, so here you see I put slightly more parts, and so it calculated the time at 5.25. So when we are in bulk mode, it will try to get the belt speed or cycle time so that the parts per hour we enter will cover the belt around 80%. So 80% is the rule of thumb we use for most application. 80% is just enough space for parts to nest together properly on the belt so that they don't move around or roll through the chamber. For some parts, you may want to have a lower belt coverage. For parts with legs that tend to tangle, then we can increase the speed, shorten the time, so we will get lower belt coverage. And for some other parts, sometime we can go, if we want to go to 2 layers or 3 layers of parts, then we'll go to higher belt coverage, so that would be like a layer and a half. So when I change the time, you see the stress temperature gets adjusted. So the shorter the time, when we go to shorter time, we need to go slightly higher temperature. So when you start to fiddle with the numbers manually, make sure you adjust your temperature to reach the stress temperature. As you can see, if I stay in the oven longer, then the stress temperature is slightly lower. So that's it for the introduction. If you have any questions, just email us. It will be a pleasure to answer your question, give training over Teams meeting, or make videos like this.